about a particular type of application problems. It's called work, and it has to do with a person doing a certain job in a particular amount of time, and say another person does a particular job in a particular amount of time. How long would it take both of those people working together to do a job? And it applies more than just a job. It could apply to how fast you fill up a swimming pool or something like that. So here's an example, and I'm going to explain it using this example. I think that's the best way to get started. So we have one gardener can mow a golf course in 4 hours. So this one guy or girl by themselves can mow a golf course in 4 hours, while another gardener can mow the same golf course in 6 hours, okay? So the second person takes a little longer to mow the golf course. It could have to do with the person, it could have to do with the equipment, but it doesn't matter why. We're not going to get started on that. Let's just think about one person mowing a golf course in 4 hours, okay? So you got to think about how much could they mow in 1 hour. Let's just say they were mowing 1 hour. Would you agree that's 1/4 of the golf course? Because if they can mow it all in 4 hours, if you only work in 1/4 of that, that would be 1/4 of the job. So one person could do 1/4 of the job in 1 hour. What about the other person? Well, it says he can mow the golf course, or she, in 6 hours. So the other person can do 1/6 of the job in a single hour. And the question is, how long would it take them to do the job together? So if you think about if they work together for 1 hour, it would be 1 over, we don't know, and I'm just going to put T of the job, okay? Now, the best way to think about this is you've got this rate for one person added to this rate, and if you add the two rates together, it's going to equal the rate of them together. So you could say the rate alone for one person plus the rate alone for another person equals the rate together. Okay, so let's talk about how you would solve this equation. So I'm going to do this all in one color. How about we do it in red? So you've got 1/4, because the first person can do 1/4 of the job in an hour, plus the second person can do 1/6 of the job in an hour, and that's going to equal 1 over T, because we don't know how much of the job can be done in an hour if they work together. You know, it's going to take less than 4 or 6 hours, isn't it? Hopefully it's going to be a lot faster than the 4 hours. So now we have a rational equation to solve. So here's your equation. I'm going to block it off so you can really see it. So 1 over an alone plus 1 over an alone equals 1 over together. And that's the way I like to think about these every single time. Okay? So let's solve this equation now. To solve this equation, you need to solve a rational equation, and the best way to do that is to what we call clear fractions, right? You want to multiply every one of your fractions on both sides of the equation, or every one of your terms, I should say, by the least common denominator. Okay, so I'm looking at a 4 and a 6 and a 10. Now I need a value that 4 and 6 divide evenly into, and T. Did I say 10 and T? So a value that 4, 6, and T divide evenly into. Now a value that 4 and 6 divides into is 12, right? And then to get that extra T, we need 12T. So listen, y'all, we're going to multiply every one of these by 12T. So let me write that down. We're going to have 12T times 1/4 plus 12T times 1/6. I was doing that in red, why not? Okay, and then equals 12T times 1 over T. Now, if you watch the information about solving rational equations, you already know how to do this, but I'm going over it in detail just in case. Now, the reason we did that is so we can clear fractions. Look, this 4 goes into this 12 3 times, and so when I multiply that together, that's going to be 3t times 1, which is 3t. This 6 goes into this 12 2 times. When I multiply that together, 2 times t times 1 is 2t. And then over here, this t and this t cancel, and you have 12 times 1, which is 12. So I'm going to write down what I just said. I've got first term, 3 times t times 1 is 3t. Second term, 2 times t times 1 plus 2t equals, and on the other side, that's going to be just 12. I solved this equation. 3t plus 2t is 5t equals 12. This is just a linear equation now that we divide both sides by 5. So my answer is t is 12 fifths. 12 fifths of what? Okay. Remember the other was in terms of hours, right? So this is 12 fifths hours, and that might not mean a lot to you. How long is 12 fifths? Well, if you think about it as a decimal, you do 12 divided by 5. Just type it in your calculator. 12 divided by 5 would give you 2.4 hours. Okay. Or you could think about it as a mixed number. 5 goes into 12 2 times, and then there is 2 left over, so 2 and 2 fifths, which is 2.4. But what if it wanted it in terms of hours and minutes? So it would be, I'm going to the top of the page up here, so it would be 2 hours, and then you have to change that 0.4 to minutes. To do that, you have to multiply it by 60, right? Because that's 0.4 of an hour, and there's 60 minutes in every hour, and 0.4 times 60 is equal to 24 minutes. So this will be 2 hours, 24 minutes. Now, how do you know if you need to do all that? Well, it depends on how it asks the question. This says, how long would it take if the two gardeners worked together to mow the golf course? It doesn't tell you, it wants it in hours and minutes. So really 12 fifths of an hour would be fine. I think 2.4 hours makes it very clear. But 2 hours and 24 minutes is if they asked for hours and minutes. So just be careful. This one did not specify hours and minutes, but your homework does. So be very careful about that. Okay, let's try another one. All right, Carrie can weed the garden in 7 hours. This is by herself, 7 hours. Well, her mother can do it in 3 hours. It doesn't say 3 hours, but it does imply 3 hours. How long will it take the two of them working together? So remember, kind of just a general formula, 1 over alone, that's a rate, plus 1 over the other person alone, again, that's a rate, is equal to 1 over the together time. And it's really, there's your formula right there. 1 over one person alone plus 1 over the other person alone equals 1 over together time. And again, this is rate 1 plus rate 2 equals rate together. So Carrie, by herself, we could say that's 1 over 7. Plus her mom, that would be 1 over 3, because she can do it in 3 hours. But we don't know how fast they can do it together. That's what we're looking for, so that's 1 over t. And once again, we're trying to solve this equation. 1/7 plus 1/3 equals 1 over t. The way to do that is multiply by the least common denominator. What is that? Well, 7 times 3 times t is 21t. Unlike the last problem, 7 and 3, the greatest common factor is just if you multiply them together, because they don't have any common factors. So what I need to do is multiply each one of these by 21t. So I'm going to kind of do it right in front of my work here. 21t times 1/7, 21t times 1/3, and then 21t times 1 over t. Okay? Why did I do that? So I can cancel this 7 and this 21, and that's going to give me 3 times t times 1, which is 3t. Right? Did you catch that? Because 7 goes in 21 3 times. 3 times this t that's still there times 1 is 3t. Let's try it again. 3 goes into 21 7 times. This 7 times this t times this 1 is 7t. And then on the other side, this t cancels with this t, and I'll have 1 times 21, which is 21. And y'all just call them clearing fractions. So now you simplify this linear equation. You have 3t plus 7t is 10. T is equal to 21. divide both sides by 10, and t is 21/10 hours. Since we were originally given hours, our units in hours. Now, what does that really mean? Okay, so that's an acceptable answer as far as I'm concerned, but your problem might ask for a decimal, or it might ask for hours and minutes. So let's do both. If I do 21 divided by 10 in my calculator, that's going to give me 2.1 hours. Okay, so together they can weed the garden in 2.1 hours. But what if it said hours and minutes? Well, we know the 2 is the hours, but we have to change 0.1 to minutes. How do you do that? You take that decimal and multiply it by 60 minutes, and 0.1 times 60 gives you 6 minutes. So my final answer is 2 hours, 6 minutes, and they are finished weeding the garden. Okay, let's try another one. So we got 2 hoses can fill a swimming pool in 10 hours. It would take one hose 26 hours to fill the pool by itself. How long would it take for the other hose working alone to fill the pool? So apparently the 2 different types of hoses fill the pool up in a different rate. So either they're coming from a different water source or they're a different size hose. But either way, it's at a different rate. So we know that the one hose can fill the pool in 10 hours, right? So that rate would be 1/10 of the job would be done in an hour. And remember how we do it. We do 1 over alone is one rate, plus 1 over the other situation alone is the other rate, equals 1 over together. That's the way we think about this. Okay, so alone, that would be 1/10, plus, now, what about the other hose? Okay, we know that it would take 26 hours to fill the pool. See, 2 hoses fill. Oh, whoa. I didn't read. 2 hoses can fill the pool in 10 hours. One alone is 26 hours, so that's 1 over 26. That's an alone rate. We don't know how long it would take the other one, so we're going to say 1 over t. That's another alone rate, where t stands for time, not together, time. Now, the together rate we know is 10 hours. That makes sense, right? That together it wouldn't take nearly as long as each of them alone. We know, again, one hose by itself is 26 hours, so that'd be 1 over 26 of the pool would be filled in an hour. The other, we don't know, so that's 1 over t hours would be the rate in 1 hour. And we do know together they could fill 1/10 of the pool in an hour, or fill it up in 10 hours. So this is the equation we're trying to solve. Now remember, the rule is multiply by the least common denominator for 26, t, and 10. What would that be? You could just multiply 26 times t times 10. But the least common denominator would actually be 130t, because 26 divides into 130, and so does 10. So that's what I'm going to use. But listen, nothing wrong with using 260t, which is 26 times t times 10. All of them multiplied together. So remember, the plan is I'm going to multiply by 130t, or 260t if you prefer, times every term. So notice that's 130t times 1 over 26, 130t times 1 over t, 130t times 1 over 10. And I'm going to simplify. So you know 130 divided by 26, when I clear fractions, is 5. Okay, so I'm canceling 26, 130 leaves 5t. So that's going to be 5 times t times 1, which is 5t. Right here, the t and the t cancel, so 1 times 130 is plus 130. And over here, 10 goes into 130 13 times, and 1 times 13 times t is 13t. Now I have a linear equation that has been cleared of fractions, so I just need to solve for t. Now notice in this particular situation, I have t's on both sides of the equation. I need all my t's on the same side. So I have two choices. I could subtract 5t from both sides, or I could subtract 13t. I think it'd be much easier just to subtract 5t from both sides. Okay, that gives me 130 is equal to 8t. 13t minus 5t is 8t. Now I'm going to divide each side of the equation by 8. Okay. Now, I don't know that 130 divides by 8. It doesn't. It gives me a decimal. So my t is 16.25. Now, 16.25 what? Well, remember, 10 hours was used, 26 hours were used, so our rates were in hours. So this is in hours. So that would be an appropriate answer unless it wanted to know hours and minutes. So if it wanted to know hours and minutes, we know the 16 hours, the whole number part, but we would have to take the decimal part, 0.25 hours, and change it to minutes by multiplying that by 60 minutes. So that's 16 hours, and 0.25 or 25 hundredths times 60 is going to be 15, and now that's in minutes. So we're talking 16 hours, 15 minutes to, well, for the hose, one of the hoses to fill the pool alone. So it takes 26 hours for one of the hoses to fill the pool. It takes 16 hours and 15 minutes for another hose to fill the pool, but if they work together, you could fill that pool in 10 hours. Okay, kind of getting the hang of it? Alright, so we have a fourth work problem. It takes Tina 3 hours to frost her holiday cookies. But if Candy helps her, it takes 2 hours. So notice the 2 hours is if Tina and Candy are working together. How long would it take Candy to frost the holiday cookies by herself? So just as a reminder, a rate of 1 over an alone time plus 1 over the other alone time is equal to 1 over together time. Okay, so it takes Tina 3 hours to frost her holiday cookies. So that's an alone time, right? So that's 1 over 3, or Tina can do 1/3 of the cookies in 1 hour. That's where the rate comes from. Plus another alone time. Do we have another alone time? Well, no, because the 2 hours is if they work together. So that must go over here in the together time. That's 1 over 2, or half the cookies in an hour. And what we're missing is Candy by herself. That's the one we don't know. So we're going to say that's 1 over t, where t is the time for Candy to frost the cookies all by herself. So by now, you know the drill. We need to multiply this by the least common denominator. For 3t and 2, we know that is 6t. So I'm going to multiply all 3 of these fractions by 6t. Why? Because it clears the fractions. So what happens is 3 divides into 6 2 times, so that just simplifies, and now we have 2 times t times 1, which is 2t. And then plus comes straight down. Now this t cancels with that t, and we're left with 6 times 1. And then equals comes straight down, and this 2 divides into 6 3 times, and 1 times 3 times t is 3t. Now the next step is to solve this linear equation. To do that, I need all of my t's on the same side of the equation. So what I'm going to do is subtract 2t from both sides of this equation. Of course, they cancel over here. I'm left with 6 on the left side, and we know 3t subtract 2t is 1t, or just t. And y'all, that's my answer. That it takes Candy 6 hours to frost the cookies if she were working alone. And this is a final problem, y'all. This is a question directly out of the homework. I wanted you to see how one of these reads. It says, Mary can clean her apartment in 6 hours, while her roommate can clean the apartment in 5 hours. These are alone times, right? If they work together, how long would it take them to clean the apartment? Notice it says round your answer to the nearest minute, which means they want this answer in hours and minutes, okay? So Mary can clean her apartment in 6 hours. So that would be 1/6 is the rate. So she can get 1/6 of the apartment done in an hour, and her roommate can clean the apartment in 5 hours. So we're going to add that to her rate, which is 1/5 of the apartment can get cleaned in an hour, equals what we really want to know is how fast can they do this together. And since we don't know that, I put T in the bottom to represent the time that it takes for them to clean the apartment together. So you know the next step, multiply by the least common denominator. 6 times 5 times T is just 30T because 6 and 5 don't have any common factors. So I'm going to multiply each one of these fractions by 30T. Why? So I can clear the fractions and my problem wouldn't have any more fractions in it. Alright, so 6 divides into 30 5 times. And notice what we have left. 5 times T times 1 is 5T. Let's try that again. For the second fraction, 5 divides into 30 6 times. And then we have 6 times T times 1, so that's plus 6T. The 5 in the bottom is gone. The 6 in the bottom is gone. Now on the right hand side of the equal sign, the T's cancel, and I have 1 times 30 is 30. Now I add my like terms on the left. 5T plus 6T is 11T equals to 30. To solve for T, I divide each side by 11. That's going to give me an answer of T is equal to 30 divided by 11. But fact is, they don't want to know 30 divided by 11. They want to know, first of all, what the decimal version of that is. Now, careful here, that's 2.7272727. That keeps going, okay? So what we need to do is take that decimal, because that's what you got to convert to minutes. Remember, this is your hours, so now we know we have 2 hours. But I'm going to leave that 0.727272 in my calculator by just subtracting the 2 off. So I'm going to minus 2, and now my calculator reads 0.727272. And remember, I multiply that times 60 without the 2 there, right? Times 60 to get my minutes. So 0.72727272 times 60 gives me 43.636363, and that keeps going minutes. Now careful, remember the problem said round your answer to the nearest minute. So if I round that to the nearest minute, now I'm going to have 2 hours and 44 minutes. Now y'all haven't typed this in to see if that's right. I assume they wanted in hours and minutes. What if they wanted it in just minutes? What would I do? Well, I'd have to multiply that 2 times 60 also, which would be 120 minutes plus 44 minutes. What's 120 plus 44? 164 minutes. So that's a possibility, but I think the 2 hours and 44 minutes is the way to go. But anytime you need to convert an hour to minutes, just multiply by 60, right? All right, I hope this gets you through work. If you have any questions or you run into a homework problem that just doesn't make sense, send it to me, okay? I'll be glad to help you out. I hope you have a wonderful day.